I plugged in a lot of like some of the more basic like numbers like 0 and didn't really get
Yes,
anywhere.
and what have you reached?
I didn't really reach anything.
Okay, so here, for example, here we have this complicated term and this complicated term, right?
Yeah.
Okay, so and f is from real number to real number. So x is equal to y is equal to 0. So f of 2, f of 0 is what?
F of negative f of 0 plus f of 0 plus 0.
Yes. So let's consider only x0. Then we have what? F of 2, f of 0, right? Is
Yep.
equal to f of negative f of y plus what? Plus f of 0 plus y, right?
Y. Yeah.
Let's consider only y is equal to 0. So f of what?
Then f of 2 f of x equals f of x minus f of 0
Yes.
equals not equals plus f of x and plus 0.
Yes, plus 0 again. Okay, so if we pay attention to these things, can we reach any good result? F of 2, f of negative f of x. We reach this. C plus y, so. And we have f of 0, we have lots of f of 0s.
Yeah.
So can we, for example, write something to cancel some terms? Like exactly the JMO problem the BMO problem that we try to get rid of complicated term. Here we can do what to get rid of, for example, this term.
You can substitute it out.
We can have same x but change only y, right?
Yeah.
Okay, so y, for example, is equal to z. So f of 2, f of x is equal to what?
F of 2 of f of x is equal to f of x minus f of z plus
Yes.
f of x plus z.
Then we should do what? Subtract to get rid of this, right? So 0 is equal to what? F of x minus f of y plus f of x minus f of x minus f of z minus f of x, right? And we can cancel f of x, so y z, right? Y here and z here. So we can say f of x minus f of y plus y is equal to f of x minus f of z plus z, right?
Yeah, but y is equal to z, so it simplifies more.
No. You cannot say y is equal to z. Here y is equal to z. Okay, y is equal to z means instead of y you write z. Okay, you can't say this one in this one also y is equal to z. Understood?
Oh, oops. Okay.
Okay, now here, for example, again, let's consider sometimes in the middle of the solution. If x is 0, then what can we conclude?
If x is 0, then you get f of negative f of y plus y equals f of negative f of z plus z.
Yes. So let's call this one, for example, 1, and a result that may be useful. And this one 2, right?
Yeah.
Okay, again, here we have two variables. Let's write, for example, here in terms of yx. So it would be f of negative f of x, for example, plus x. And let's change z to 0. So it is equal to f of negative f of 0, right?
Mm-hmm.
So here we've concluded f of negative f of x is equal to negative x, right? Plus this one. Do you agree this value is a constant?
Yeah.
So we can consider again it is c negative x plus c, right?
Uh-huh.
So it is our third result. Now we found f of negative f of x. So in the points that I told you last session, I told you sometimes you should check is f 1 to 1 or not, okay? And the definition is this. You know 1 to 1 means what?
Yeah.
You should prove that if f of a is equal to f of b, then a is equal to b, okay? So in
Mm-hmm.
this function, try to prove f is a 1 to 1 function, okay?
Using these three things.
Using these things and the equation and see which of them useful, okay? They are all things. You have all things that you need, okay?
Okay. Oh, okay, wait. So if I set f of a equals to f of b,
Mm-hmm.
and then I would I first set x is just x, and then I can set y equals a, and then y equals b. So I first get f to f of x equals fx minus f of a plus fx plus a.
Let me write, can you say it again? F of 2f of x is equal to what?
Fx minus f of a plus f of x plus a.
Yes.
And then I do the same thing for b. So now I get f2 of f of x equals fx minus f of b plus f of x plus b.
Yes.
And so now the first two terms on both for both equations are the same because f of a equals f of b. So that's the same. That's the same. F of x is also the same as f of x. So then I just get a equals b.
Exactly. So solution 1 was this. Solution 2, you can use third one. When f of a is equal to f of b, so do you agree we can conclude f of negative f of a if you replace here a and b? Do you agree they are equal?
Yeah.
So then we can conclude what terms are equal.
F of a equals f of b.
No. F of a is equal to f of b. F of this is equal to this if you use third one. Then what can we conclude?
Negative a plus c equals negative b plus c.
Yes, so
So
we
a
can
equals b.
exactly. Okay, it was my solution was this, your solution was this. Good job. Now here, let me tell you, you know 1 to 1 is what, but why it is so much useful when f is 1 to 1. If you know f of some terms is equal to f of some terms, you can cancel these two f's. Agreed? Because the thing insides are equal, right?
Yeah.
Okay, so f is 1 to 1 as fourth result. So let's consider, for example, this result that we reached. Third one. and f is 1 to 1. We have also this equation. So because we can cancel f because f is 1 to 1, it's good to replace x and y with what to reach something like this and cancel f's?
Not sure here what to do here.
Look, I want to replace x or y with something to reach f of something is equal to f of something. Here, you should replace x or y with what to reach f of something is equal to f of something.
Y equals negative fx. Works. Okay.
Well, exactly. Because y is equal. Look, f is 1 to 1. Always, usually, the students think of it as a is equal to b. If f of a is equal to f of b, then a is equal to f of b. A is equal to b. But if you think like this, that you can cancel f's, it helps you to consider this, that y is equal to negative f of x. Then it would be f of 2f of x is equal to what?
F of x minus f of negative f of x.
Yes, then we can conclude what?
So 2f of x equals x minus f of negative f of x.
And f of negative f of x is what?
1 second. F of negative f of x is negative x plus c.
X plus c, yes. Negative
x plus c.
negative x plus c, yes. So it
Yeah.
would be what then?
2x minus c.
So f of x would be what?
X minus c over 2.
Yes, so now try to solve. And c was what? Remember c was what?
C is f of negative f of 0.
Yes. Okay, now try to solve the rest.
I got to f negative f of 0 equals f negative f of y plus y, but now I'm kind of stuck.
Okay, so look, because we don't want to have fractions, do you agree I want to replace. We can say this x plus k. K is negative c over 2, right?
Okay.
Now let's rewrite this. Left hand side would be what? In terms of x and k, left hand side would be what?
f2x plus 2k.
Let's say it is x plus k, and then f of this is the thing inside 2x plus 2k plus k, 2x plus 3k, right?
Yeah.
Now this one is what? F of y is y plus k, right? So x minus y minus k plus k, agreed? Plus x plus k plus y, right?
Yeah.
So we can cancel y, we can cancel k's, so it would be 2x plus k, right? So what was the hard part of this that you said you couldn't solve?
I was trying to do something else. I didn't.
No, you should look
again,
at the end when you want to find c. It is so much good. We know f of x in terms of x and c. Only replace. And 2x plus 3k is equal to 2x plus k. So 2k is equal to 0. So k is equal to 0, right?
Yeah.
So f of x is equal to what?
X.
X. For all values of x. Then at the end, try to check for x, okay? To make sure. You said what?
I was trying to like do something else that didn't really work for some reason.
Want to check your approach, or that's okay?
If I had this, I set y to 0. I had that equation. I set y to 0.
No, you shouldn't. We can do that, but when we know f of x is what, only replace and find. When you say y is
Yeah,
equal to 0, it is a special case, right? Because look,
yeah,
f of x is a specific function. We know it is exactly what. You should only replace and find c is what. You don't need to consider special cases, okay? For example,
okay.
here, when I want to check this, I don't consider special case because I should check. Left hand side is 2x, right?
Mm-hmm.
Right hand side is x minus y plus x plus y. And they are equal,
Yeah,
right? So we checked.
yeah,
Always check and write this part in your answer sheet, okay?
yeah.
Because in some cases, in some problems, when we reach something like this, we reach that, for example, we don't have any value of c that satisfies this. So you say there is no good function, okay? At the end, when you check, you understand that, okay?
Okay.
That's the reason that you should always check. So we should solve all these problems with these ideas.